In the first video for this chapter, we talked about acids and bases. So now we're going to talk about reactions of acids and bases. Well, let's quickly redefine acids and bases. Well, your acid dissociates to form H plus ions. A base dissociates in solution to form hydroxide ions. There are other definitions of acids and bases, and we'll talk about other definitions of acids and bases in university chemistry too. So for now, an acid is a compound that dissociates to form H plus ions, and a base is a compound that dissociates to form hydroxide ions in aqueous solutions. A reaction between an acid and a base is called a neutralization reaction. When an acid and a metal hydroxide base react, an ionic compound or salt and water are produced. Just like precipitation reactions, neutralization reactions can also be written as molecular equations, complete ionic equations, and net ionic equations. So we know that hydrochloric acid is a strong acid. So in water, it will dissociate completely to form H plus ions and chloride ions. Okay. Sodium hydroxide is a strong base. It will dissociate completely in water to form sodium ions and hydroxide ions. Water is formed by combining the H plus ions with the hydroxide ions. And sodium and chloride ions are spectator ions. So our complete ionic equation is H plus. So our overall equation is H plus aqueous plus OH minus aqueous produces H2O liquid. Now that we've defined acids and bases and how to identify them, let's see what types of other neutralization reactions occur when acid comes into contact with a base. These are neutralization reactions with gas formation. The acid-base neutralization still forms a salt and water, but in this type of neutralization, we also produce a gaseous product. And these neutralization reactions that produce a gas are usually going to be composed of an acid reacting with a salt containing the carbonate ion, or an acid reacting with a salt containing the bicarbonate ion. We also have the neutralization reaction where an acid and salt containing the sulfide ion forms a gas, and an acid plus a salt containing the sulfite ion with the formula SO3 2-. When the carbonate and bicarbonate reacts with an acid, the products are a salt, carbon dioxide, and water. Let's take a look at the reaction of calcium carbonate reacting with 2 moles of hydrochloric acid. This will produce of calcium chloride and 1 mole of carbonic acid. Now carbonic acid decomposes to water and carbon dioxide rapidly. So if we were to visualize this reaction, we'd actually see little bubbles of carbon dioxide forming in this reaction. So our overall reaction is calcium carbonate reacting with 2 moles of hydrochloric acid produce liquid water, carbon dioxide gas, and calcium chloride. We can also have an acid react with a salt containing the sulfite ion. Let's take a look at the example of sodium sulfite reacting with hydrobromic acid. This produces aqueous sodium bromide and hydrogen sulfite. So this H2SO3 is going to decompose, and this is going to decompose into water plus SO2 gas. And we'll have the sodium bromide in our reaction, so the overall reaction is sodium sulfite reacts with 2 hydrobromic acid molecules to form 2 sodium bromide molecules, water, and sulfur dioxide. And our last example is with an acid reacting with a salt containing a sulfide. So here we have the example of sodium sulfide reacting with sulfuric acid. And this is going to give us aqueous sodium sulfate and dihydrogen sulfide. gas. So this reaction is quite a stinky reaction. Here, H2S, hydrogen sulfide, smells like rotten eggs. So our gaseous products produced in this reaction are H2S. So that's what we have for acid and base reactions, or neutralization reactions. Now guys, make sure you know what acids and bases are, know the strong acids and strong bases, and know how we define a salt. You should also be able to predict the products of neutralization reactions, including predicting the products of neutralization reactions that produce gaseous products.